Hello, and welcome to the three-phase AC induction motor video. This was recorded in May of 2010. Here is the schematic of the two-pole, three-phase, induction motor.
On the outside we have the stator, which is made up of a transformer core. It's kind of hard to tell, but this is an E section right here. We have a piece of metal essentially coming through the coil to concentrate the magnetic field, and we also have the I section right here linking all of the E sections together. And as you can see, you got 6 coils in total. This coil and this coil are wired in series, and same goes for this coil, this coil, and this coil, and this coil. And in the center we have the rotor, which is made up of a coffee can, basically cut down. And so to power it, we have a three-phase power supply here, adjustable voltage, and we're also monitoring the current. So we're just going to turn up the voltage here. Hopefully it works.
Not bad. About 550 RPM. Just kidding, that's crappy.
That's spinning happily right there. Okay, it's spinning about as fast as it's going to get going. And if we look here, we have about 800 milliamps or so for each phase, except for one of the phases is drawing a little bit less, which is probably because of different amount of windings or different amount of resistance in one of the coils. You can also see that we're drawing about 45 volts for one of the phases. Okay, so we're going to turn off the power and let it spin down, and we will try a different rotor and see what happens. Rotor number 2. Okay, so for part 2 of the demonstration, we replaced the original rotor with a smaller one to see if the magnetic field was strong enough to reach all the way to the can and all the way to the other side for each one of the poles. So the professor, who frankly doesn't know what he's talking about half the time, said that the field wasn't strong enough to cut through the rotor and go to the other side. And he also said that the field was going upward for some reason, and that's just plain wrong. But anyways, we installed the second rotor here, and we'll apply some voltage and see what happens. So it makes a bit more noise, and it doesn't start up as fast. That's just due to the wider gap right here, but it does work. And that concludes test number 2. Okay, so we put this spiral pattern on top of the rotor just to get the psychedelic effect. Okay, let's apply power and see what happens. Okay, for the final test, we removed 3 of the coils, and the remaining 3 coils are wired in a delta configuration, something like this right here. Okay, so applying some voltage, let's see what happens. Okay, so you can see it didn't get going very fast, probably because the flux has to actually travel from this coil through the rotor over to this coil. So it's not a straight path. Most of it wants to go straight across, so you have a limited amount coming into this one. So that sort of proves that it might work, but it's obviously not spinning the rotor as fast as before. So either the design needs changed, or it's just a bad idea to begin with. Okay, that concludes the video, and thanks for watching. Here's another test where we're going to put a DC current through the coil and see if it can attract the can from that distance. Okay, turning up the current.